In this clip, we're going to be looking at how to draw and interpret box plots. To draw a box plot, we need 5 pieces of information. We need the lowest value, the lower quartile, the median, the upper quartile, and the highest value. To find these from this raw data, I need to put these numbers in order first of all. I always start with the median. That's the middle value in my list of values, so that's this number here, 11. Next, I find the lower quartile. To do this, I find the middle of all the numbers to the left of the median. I don't include the median in this, I'm just looking at these numbers here, and the middle number is 7. For the upper quartile, I do the same thing on the numbers to the right of the median, so that's these ones here, and the middle number is 20. The lowest value is straightforward, that's 4. And the highest value is also straightforward, that's 27. I now want to plot these values on this grid to create my box plot. This is what my finished box plot looks like. I'm now going to show you how to draw this. I started by plotting these 5 lines here. You'll see that they correspond to these 5 values. So for example, this one here is plotted at 4, and this one is plotted at 7. There's no real rules for how long these are, or how high up away from the bottom they are. What I like to do is try to keep them in the middle, and I tend to make them 4 squares long each. I now draw the box part of the box plot by joining my lower quartile to my upper quartile, here and here. Notice that the median gets trapped inside the box. I then join the lowest and highest values to the box to create what are known as whiskers. We draw box plots because they help us visually represent distributions. We can see the median, the lower quartile and upper quartile, and the interquartile range is the length of the box. Because we've also got the lowest and highest values, the range is the whole length of the box plot. Here's a question for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Here's a much more difficult question for you to try. I'm going to give you one clue, and that's to remember that 50% of the data is below the median. Press pause and have a go. When you're ready, press play. Here's the answer. You needed to realise that if 25% of people were under 24 years old, this is the lower quartile. 50% were under 36, so that's the median. We're told the interquartile range is 27, but we need the upper quartile for our box plot. We can get this by adding the interquartile range to the lower quartile. That gives us 51. We're then also told the lowest value and the highest value. Once we've done all that, we can draw our box plot. Now in this question, I'm being asked to compare 2 box plots instead of drawing them. I want to use them to compare the distributions of the waiting times at 2 different surgeries. Whenever you're asked to do this on an exam, they'll be looking for 2 out of 3 possible answers. You can compare the medians, the interquartile ranges, or the ranges. So if I wanted to compare the medians here, I would write that the median waiting time is the same at both surgeries. If I wanted to compare the interquartile ranges, I would write that surgery 2 has a larger interquartile range because the box for surgery 2 is longer. If I wanted to compare the ranges, I would write that surgery 2 has a larger range of waiting times because the overall box plot for surgery 2 is longer. Of course, with these 2, you could write it the other way. Surgery 1 has a smaller interquartile range, and surgery 1 has a smaller range. Remember, on the exam, this type of question will usually be worth 2 marks, and they will only want 2 out of these 3 possible answers. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the possible answers you could write down. Remember, you'll usually need 2 of these, but a good tip is to look how many marks the question is worth. If it's worth 2 marks, you'll need 2 answers. If it's worth 3 marks, you'll need 3.